Thank you. Thank you for being here. I stand in the way between you and the exciting conclusion of the first day of the conference. My name is Zurab, and I am a software engineer at LaunchDarkly. I'm going to talk about feature flagging using the LaunchDarkly service and my work on the Erlang Elixir SDK client. So I'm going to cover several things. I'm going to cover the feature flagging basics, then going to focus a little bit on the LaunchDarkly implementation, and in both of which will be relevant to the SDK implementation, and then hopefully we have a little bit of time for the quick demo at the end. So let's get right to it. So feature flags, what are feature flags? Just by raise of hands, how many of you are familiar with the term of feature flags? And excellent. And how many of you actively use feature flags in your normal development process? Not as many. Okay. Okay, so let's start with at the top. What is a feature flag? Well, conceptually, it's quite simple. It is a control point in your code which can alter your application's behavior depending on external input. Okay, but wait, you might say, why would you want an external source to control the behavior of your application? Are you crazy? Maybe, maybe not. So it turns out one of the primary use cases for feature flags is to decouple the deployments from releases. So that way you can release more frequently and turn things on gradually when they're ready. Let's talk a little bit more about release management. The things you can do is target individual users or segments of users with your new features. You can test fixes or new features in production before rolling out to the whole audience. And you can let your product owners control when the features are released instead of having the development team be fully controlling the deployment. You can also think of this as a short-term and long-term feature flags. Under the short-term, I already mentioned the release management. You can also use them as kill switches, so for bug fixes or features that do not work out so well. You can also validate your changes on a smaller scale before fully rolling them out or shutting them down, depending on the results of that validation test. On the long-term side, you could use feature flags to support functionality of your application. So feature flags are all great and useful, but how do we use them? Well, we evaluate them. But what does it mean to evaluate a flag? Well, here's a code sample. To evaluate the flag, we call a function and pass it a flag key and then a user object and get the result of the evaluation. In this case, let's say we have a new one-click checkout feature and we pass it the key of the flag, the user, for whom we want to evaluate this flag. And then depending on the result of that evaluation, we either perform the new one-click checkout or we choose the path that we want to take. If the flag is on, we would do the one-click checkout, and if the flag is off, then we would do the old-style checkout that we were doing before. Okay, that's great, but what's going on underneath when we evaluate a flag? Well, there are different things that happen. I'm not going to go into detail into each one of these, but prerequisites are other flags can be prerequisites for the particular flag we're evaluating now. The flags can have targets. You can target individual users with different variations of a flag. Rules allow for more complex matching against users and rollout conditions based on, again, user properties. and then fall through if none of the above match, what is the last thing that we want to default to. Okay, now we have an idea of how feature flags, rough idea of how feature flags work. How does LaunchDarkly implement this? This part will be relevant later when I go into a little bit into SDK implementation. So LaunchDarkly provides a streaming architecture. When an SDK client is first initialized, it makes a connection to the LaunchDarkly service, and it loads the snapshot of flags and segments and stores them locally. Then the SDK maintains the streaming connection to LaunchDarkly, and only the updates are streamed to the SDK, which then updates the local state. These changes are usually propagated from the service in around 200 milliseconds from when the updates are made. And to do this, SDKs use a relatively little known, but still a standard protocol called SSE, for server-sent events. Importantly, all evaluations, because of this, all evaluations are performed locally, and they're extremely fast. If for whatever reason, LaunchDarkly service goes away, or you're disconnected from it, the SDK maintains the state of flags and segments configurations, last known configuration, and uses that to evaluate those values, the flags. Well, when the connection is reestablished, then it will it can get the refreshed configuration for flags and segments. So this makes it act like a distributed database for those evaluations for the flags. So SDK consists of 4 main parts. The first 3 we already briefly talked about, which is a streaming connection, flags and segment storage, and evaluations. The last is events. I'm not going to have a lot of time to go into details of events, but let's say that every time the evaluations are performed, they are counted, and they are then sent back to LaunchDarkly service. There are also other kinds of events for user indexing and custom event tracking, but I'm not going to go into this for now. So this is the screenshot from LaunchDarkly website. What is missing from here? There is no Erlang, Elixir, or any Beam language. So when I started LaunchDarkly last year, I thought, I can fix this. This is going to be easy. So it started as a hackathon project. We call it Moonshots. I kept adding very slowly over time. As a basic design, when we implement the SDK in most other languages, we use threads. But in Erlang, this is an OTP application. And I was starting with a simple requirement that what does it take to start an SDK client for LaunchDarkly? And all it should take is the SDK key that you have, so you can connect to the service and get your flags and segments. This all should require. But what happens under the hood? So initial design was extremely simple. There was just one top-level supervisor, and you have the streaming server and the storage server. Streaming server connects to LaunchDarkly, gets the initial payload, and then updates, passes them on to storage server, who stores it in the nets table. But we probably want different restart strategies for each, so we add a supervision layer. Now we have streaming supervisor and storage supervisor. But we also want the storage layer to be modular, so we can add custom storage behavior. So now we're not relying solely on nets. We can have, for example, an in-process map as a way to store our flags and segments. And because it's a behavior, now anyone can implement those callbacks and initialize the SDK client with the optional storage backend and supply that implementation and implement the storage for flags and segments. Another issue that came up was it is not uncommon for customers to ask that their application connect to multiple environments and projects simultaneously. What this means is that when you set up a LaunchDarkly account, LaunchDarkly gives you ability to create multiple projects. And each project can have multiple environments. So what does this mean for the SDKs? It means that SDKs would have to keep multiple streaming connections to LaunchDarkly and grab and store multiple instances of for flags and segments for each of those connections. So initially I thought, okay, I can do this easily. I'll just have multiple servers under each of those supervision layers, and that will just work fine. But I had few reservations with this, including adding repetitive complexity at each layer. So another approach was to make that structure into an instance and then have an instance supervisor that acted as an abstraction layer above that instance. Another decision that went into this was the references. So one pattern when you create a resource is to accept, is to create a resource and get a reference back, and then the host application will keep that reference for referring to that resource later down the line. This way, the application can start arbitrary number of those resources and then have to keep arbitrary number of references in its state. Another pattern is to accept a reference when you're creating a resource, and then the onus becomes on the host application to produce that reference. But one advantage of the latter one is that you don't have to, the reference can be optional. This made sense for LaunchDarkly SDK because we don't want, we don't have a use case of arbitrarily creating an arbitrarily many instances of the SDK client. We just want the ones that you specify. And then, so given this, now to start an instance with all the optional parameters, now we can give that initialization function call another reference, in this case prod, to start that instance. And the benefit being, as I said, that you can still start an instance with just the SDK key, and you can still do the evaluation just as before. So in most common of use cases where you don't use multiple instances of SDK client, you can still do a simple call, while as if you were to start another instance, you would just add another an optional reference to it. Events. So we briefly talked about the events before, and there are different kinds of events, and you can also have custom events. But here I wanted to talk a little bit about feature events. These are the events that track that a flag evaluation has occurred and its result, its variation. So these are the events are sent back to LaunchDarkly for customers' benefit. Like you consume those statistics at the end. But if we send evaluation event to LaunchDarkly in real time, that could get very inefficient. So we batch the events and send them asynchronously every 30 seconds by default. It's configurable, but 30 seconds by default. To make the process even more efficient, by default we summarize events. And so what are summary events? So most customers, again, don't want to or need high fidelity data of these evaluations. So summary events are just totals for a flag key, the evaluated variation, and the time range during which they occurred. So now the application structure looks like this with the events. You'll notice in the middle, I added another supervision subtree where we have a event server and then event dispatcher that would dispatch the events to LaunchDarkly every 30 seconds or whatever the configured interval. And this is accomplished using the send after and sending our future selves a flash message. So evaluations, I already showed you this slide. This is the steps for the evaluations. I just wanted to mention interesting implementation detail in the SDK. So a flag could have multiple rules with which you could match the user properties. And each rule could have multiple clauses. And clauses have operators. And these are the operators that LaunchDarkly supports. You could use these operators to compare any user property to any value defined in the flag rule clauses. And these operators also work on lists of values. So a fun fact that I wanted to mention is that when I initially implemented all these evaluations, the entire evaluations in the SDK, I did not use if for case expressions. I just used function clauses, which may or may not be a good idea. So let's have time for a quick demo. Bear with me while I fight technology. Okay, so I'm going to start a simple, this is not the screen you're going to be looking at, so I'm going to start a simple cowboy application, and it's going to it's just going to serve one page. I'm not good at the front end, so it's just going to say hello and the username, whatever that username is. So we'll wait for that to start. And it has started. So again, let's make sure this works. Okay, so on the left side, I have this simple application that just refreshes every second because that's the best I can do in the UI. And it just says hello and the username. And on the right side, I have the LaunchDarkly dashboard, but I have this flag selected there, which is called dark background. So I'm going to deploy this new feature, which is called dark background. So first of all, I'm not going to go into all these details in the user interface, but I'm going to turn the flag on. Let's see, turn it on, and notice nothing happened. It's because the default rule, there are no prerequisites, targets, and the rules, but the default rule is false, so it's not going to do anything. So instead of changing all of it to true at the same time, let's do a thing called percentage rollout. So let's roll it out gradually. So I'm going to drag this slider and drag it to around 30%. So let's roll it out to first 30%, or first roughly 1/3 of our user base, and save. And something stopped refreshing. So this makes the feature deploy to 1/3 of our user base, and say let's say now that these things just stop refreshing. Don't know why. Okay, so let's say that the 1/3 of the user base really likes that feature, and we want to now deploy it to 2/3. So I'm just going to drag the slider to around 2/3 and save changes, and now I'm going to have the feature deployed to 2/3 of users. Okay, so great. Now we think that everybody who's gotten this feature has given a positive result. We can either drag that slider to 100%, or we can just change the default rule to true for this flag, and now everybody has that new feature. Cool. Let's get back to, that was the quick demo. It's coming soon. I tried hard due to my own personal unplanned outage. But it's going to be, watch this space, it's going to be there. All our SDKs are open source, and this one's going to be open source as well. It's not going to be fully featured like other SDKs are, but the improvements will come along. And yeah, if there's one thing that if there's one thing that you would take away from this talk was the feature flags are cool, use them, and they let you deploy things more frequently with less risk. Thank you very much for your talk.
We have time for maybe a question or two. What is the back end of LaunchDarkly?
Backend is written in Go.
Any other questions? Sorry, have you had requests for Erlang client?
We've had some. We haven't had enough where it's justified and official. We're also a small company. I mean, we're growing, but we're still a small company. So,
used to be much smaller.
Correct. But we haven't gotten enough where there's been an official push for the client. So if you're interested, if any of this sounds interesting, give us feedback so we can properly prioritize the SDK on our end.
So what do you think of the infrastructure to publish the package? So like, is it going to be like on X, or what's the story there?
Yeah, so the plan is eventually to do everything properly. We will, at the very least, we will have the Hex package, and we will have it properly documented and released on GitHub.
And like rebar or like link, and so it's just...
It will be with rebar, yeah. We'll work with rebar.